Hi everyone. So as Itai said, my name is Udi. I'm a software engineer at Groundcover, and I'll be speaking about using eBPF for network observability in Kubernetes. So I want to start with a question to all the Kubernetes experts sitting here. How would you shortly describe what's going on in your cluster to someone who isn't familiar with it? This may sound like a simple question, but it encapsulates some deeper ones, like what is the flow of data in the cluster, which services are still using the old Postgres database you have in your cluster, which services handle the most traffic, what is the actual load of your key value store, or which services are supposed to make outbound connections. Are you still aware of that old service that intern defined a year ago and everyone since forgot? And when it comes to briefly describing complicated systems, a good approach might be to use visualization, or in our case, make a map of the cluster and all the services running inside of it. And Kubernetes objects already have some hierarchical structure that can be described visually in a pretty straightforward manner. But the real relationships, the interesting relationships between the services are the dynamic one, the network interactions between them, which are not defined in any YAML file or any CLI command. If we had those relationships in a map like this, all laid out in front of our eyes, this could help us answer the questions I've asked earlier. But relationships are complicated, especially in the cloud. And there's no kubectl describe cluster or no built-in feature in your cloud provider console to create those maps. So a couple of months ago, we at Groundcover decided to build an open source tool specifically for this task. And we named it Caretta, which is the Latin name of the sea turtles, which I learned they are excellent navigators in the oceans. And in the 8 minutes I have left, we're going to walk through how we built it and how eBPF was very useful for this sort of task. So let's go on with defining our requirements from Caretta. First, we need to observe all the connections, of course. Besides that, we want to speak in the cluster's language, use the meaningful names of the different workloads and different services. We also want Caretta to work without any changes to the cluster, specifically without any need for instrumentation of any application. And of course, we want the final result to be a visual representation of the data we acquired. And we'll split our task to 4 steps, and we'll start with acquiring the network data. Okay, so how can we get all the connections in the cluster without any instrumentation or any modifications to the cluster? So you probably guessed it. We're going to be doing it using a technology named eBPF. And I guess most of you have heard the term eBPF before, or maybe even some sort of this definition, a technology that runs sandboxed programs in the Linux kernel. But what it actually means is this. eBPF lets us run read-only programs in the context that actually manages the system itself in a way that is safe, dynamic, portable, and efficient. Let's break this down. Safe refers to the read-only part. eBPF programs are sandboxed and verified to have no implications on the system itself. So it can't crash the system or block any call or something like that. Dynamic means easy and instant deployment. eBPF programs can be loaded from a simple application, don't need to install any kernel module or reboot anything, it just works instantly. Portable refers to the ability of the developers of eBPF programs to write code that is suitable for any modern Linux version or architecture without doing specific things for any version. And efficient refers to JIT and to another methods used by the eBPF sandbox to run the programs with very little overhead. But the most important, the most special thing about eBPF is a superpower they have called probes. eBPF programs are not just code floating in the kernel, but they can be executed in the right context. we can attach an eBPF program to the beginning or end of almost any function in the system and observe closely when it's been called, which data it received, and what it has done with it. Or back to our example, we can look at the TCP stack, which is the portion of code that makes TCP connections happen in the Linux kernel. And we learned that it is triggered by various system calls by the applications, but all the interesting flows are going through this function called TCP data queue, which receives an object of type sock, which is the kernel way of describing a connection. And with the power of eBPF probes, we can write C code that will become part of this function. So every time this function is called, this code will be run as well, and it will be notified of all the different socks, all the different connections the kernel is processing. Now, it's important to note now that eBPF is not entirely new. Most of its features are in the Linux kernel since 2015, and it's probably existing in your Kubernetes nodes already, the support for it. And in the time since then, a lot of different organizations have been leveraging eBPF for the users, but it's still not very common in user-facing applications. Okay, so back to building Caretta. We have those objects, those sock objects, which describe every connection in the kernel. And each of these objects have also the addresses of the source and the destination, and also the ports being used, and also other useful information like what is the throughput that went through this connection, or we can even get who is the server and who is the client data that will be very useful for us in the future. So the next step will be aggregating all the different connections and start preparing to process it. A typical Kubernetes cluster has tons of connections, millions of connections each day, and if every time we'll need to process this amount of objects, it will be very hard, very CPU intensive. So the first step will be reducing all the different connections and get rid of all the data we don't need, like the ephemeral ports being used by the client. This can help us deal with the enormous amount of connections. The next part will be translating the raw IP addresses to the meaningful names. And we can use the Kubernetes API to maintain some reverse phone book to translate an IP address to a meaningful name. And here as well, if we don't do some optimization regarding the scale, this time we'll have a huge memory problem. Clusters, Kubernetes clusters are pretty big and changing a lot. So here as well, we need to get rid of a lot of unneeded data. And for the last step, we want to visualize the data. We can use common familiar tools like Grafana, which probably everyone here is familiar with. And Grafana has a beta panel called Node Graph, which is suitable for network graphs specifically. And of course, we can export the data to Grafana using also familiar Prometheus metrics. And when we tie everything together up, we get something like this. This is actually the microservices composed in Caretta, displayed by Caretta itself. And we can learn a couple of things from looking at this graph, for example. So I wasn't aware of this fact that Grafana, when it boots up, it actually contacts two different external services without, I don't know, I wasn't aware of it until I first saw it. It contacts both GitHub and another external service to create your avatars. And also, something that pops up is connection being made from the node itself, from the kubelet, which is the agent of Kubernetes on the node, which queries the health probe of one of our services. So I guess everyone here pretty much knows that health probes exist, but it's something we tend to forget and not really being aware of how it's actually being done. And a final, as a kicker, another good reason to use eBPF on Kubernetes environments is how easy it is to deploy. We can just load the eBPF program from a simple container and define a daemon set to load this container into each one of our nodes or each one of our kernels. So this is a video demo of a recorded video demo of Caretta. This is a simple Grafana dashboard. If there's already a Grafana in your cluster, you can just integrate it onto it. And of course, beside the map, which is nice, we can also define other visualization which query the data collected by Caretta to get a nice overview of the cluster. So I hope I convinced you that eBPF-based tracing is here, and Caretta is just an example of where it can go. And if I haven't mentioned it before, Caretta is open source, so you can view the code in GitHub, and of course, install it with a simple helm command from its README. And feel free to reach me for any question or anything in the future. Thank you.